So now that we have put the stage of what is the problem that we want to solve and how it's related with the potential causes, let's lift a little bit the curtain and see what's under the hood in a traditional broadcasting environment. So let's have a look into the usual workflow that a broadcasting environment for live stream events over the internet is comprised of. Many of you will be familiar with these kinds of setups, but it's still worth it to go over them to understand and put the context of what are we trying to solve over here. So here we have a live streaming event where you have live content coming from the left. It's being encoded in different qualities, all the way from low resolutions like 4080p, all the way up into, say, 4K like 2160p or even further, and different levels of quality in between. Whenever you have that content encoded, of course, you want to start distributing it. Here, just for simplification, say we're not putting the origin, but the origin will be essentially at that point in time. And then you deliver the content to your audience. Most of the time, you rely on content delivery networks to make this happen. Some of you may have only one CDN, one content delivery network contracted. That is the most frequent situation. But maybe some of you may have more than one CDN, essentially to avoid single points of failure, or maybe more than one CDN just to have different cost structures, things like that. And at the end of the day, what you have is a way to deliver the content through the open internet into your audience, that in this case is these two small devices on the right-hand side of the chart. So essentially, let's go over the different workflows again, so you understand the whole setup, and I'm going to rely on the pointer. Here you have the live content getting into the encoder. The encoder will have the different resolutions. It's going to be delivered into one or multiple CDNs. In this case, I'm going to use example CDN 1 in case that you have only one, but if you have multiple, it will be CDN 1, 2, and 3. Then you have the content being available on the CDN. If you have an origin shield, it will be the point of contact for that origin into the CDN. If you have just the POPs of the CDN, you will have just several devices in the audience geographic region, and then that content will be available for your audience to be consumed. And then is when the tricky part comes in. The open internet is essentially the Wild West in terms of guarantees for content delivery. You may have solutions for that, but definitely you don't have control of it. And what happens is that at the end of the day, some content may arrive in the highest quality, but maybe some content does not. And it can be anything along this chain of command. Here we're putting the focus on the interface between the CDN and the audience, but it can happen at any point, even earlier or later in this context. So even if here I'm highlighting just a red line in the CDN 1 connection, it may happen also here in CDN 2, also CDN 3, also in the connections between the CDN and the audience, or all the way back into the connections between the CDN origins and the origins backwards into the contribution stream. But at the end of the day, anything that fails here may have an impact on the quality of experience, right? So we need to essentially find a solution for when something like this happens. In this case, the situation that is happening here in this example is that, okay, maybe there is congestion between the audience ISP and the CDN1, and one potential choice will be to essentially steer the traffic to a different CDN. But what happens if that's not the problem? And many times that's not the problem. Maybe you switch the traffic to another CDN, the CDN number 2 or even number 3 may still collapse because their peer infrastructure is not good enough, the capacity is not good enough, the points of presence are cold, and you need to cache the content before you're able to serve. Many things can happen, right? So, okay, how we solve the problem at the end of the day, that is the most important thing, right? In order to understand how to make that problem solvable, we need to understand even a little bit deeper what's going on under the hood. So let me go into what is going to be the foundation for solving this. That essentially is building a broadcasting tree. And I'm going to go a little bit deeper about why it is a tree. And here is just an example of why it is a tree, but let me highlight it. You may see here that the content here in the middle is flowing through CDN2 in this case in green with the highest quality, and then it fans out here on the right-hand side with the audience. But you can see it's just one single point of entry, and then it fans out into different branches. By the way, the same happens with multiple CDNs, but at the end of the day, it's a fan-out architecture like a tree. So that's the basic fundamental thing that a broadcasting event is. It's just a source of content that you need to deliver to multiple destinations, and that by nature is a broadcasting tree, okay? Okay, so let's start with a toy example for creating a broadcasting tree, just for the sake of having the context in place. And here we're going to use not only CDN devices like points of presence or servers, but also the audience itself. The devices of the audience itself also as relaying mechanisms. Some of you may be using all these kind of technologies already, peer-to-peer technologies for expanding the CDN capacities. Maybe some of you don't use it yet, and you are using just one or multiple CDNs. It doesn't matter. At the end of the day, it's just relaying mechanisms to make the content arrive to your last mile audience. And they are just devices. If it's a CDN, it's just a set of servers that are configured, spread out around the world to make that content cached and closer to your audience. Or if you're using peer-to-peer expansion of the CDN capacity, at the end of the day, those devices are the audience devices themselves, where the content is also cached locally and can be relayed to other members of the audience. And in the end of the day, they are just computation devices, right? They have the content and they relay the content to somebody else. So let's build a tree with that, because that's the natural topology of sending the content from a source to a destination. In this toy example, we're having one CDN with a couple of fixed devices underneath. It can be end user devices that are fixed. It can be also devices from the CDN that are fixed, like points of presence, but it doesn't matter. But at the end of the day, what you need is to send the content all the way down into the audience. So here, just to recap, we have the CDN here abstraction. You may have fixed devices below that will be either end user devices or points of presence of the CDN. And then you have all the devices down below that are audience devices that are either fixed or mobile, doesn't matter. At the end of the day, they just want to receive the content and they are the source of it, right? Sorry, the destination of it. Meanwhile, we have the source on the top. This is the first principles, fundamentals of what we are doing here in our industry, is sending the content from one source into multiple destinations. Okay, so now let's see what's happening actually under the hood. So under the hood, what we have is an underlying network, the network that is essentially providing the content and the connectivity for all the actors in this exercise. That is the internet. And in order to have internet working, we all rely on internet service providers, regardless if it's the last mile for your audience, or it's just peering points between ISPs, or if it's just the managed networks that the organizations run in order to deliver the content. At the end of the day, we have an underlying network below it. But of course, it's a combination of internet service providers, because there is no single provider for the internet. That's the open internet, right? You have multiple providers to achieve the connectivity that the internet at the end is. Just by definition, internet is a net of nets that are interconnected. So that's the basic fundamentals of what we are dealing here with. And why is that relevant? Well, when you have a live event where you are delivering content from your source to the destination, you have a scenario where you have something like this, okay? Multiple devices over 2 ISPs at a minimum. Usually much more, okay? But in this toy example, there is just 2 internet service providers providing service underneath this. But what happens when there are issues in the delivery, right? Essentially, there is a congestion happening on the network delivery. It can be happening at any point in time. But just for the sake of this exercise, let's think that this happens when the event is started, a large event, live event, you are getting the audience coming by, and then is when the issue happens, right? So why is that happening when the live event is triggered and when you're getting audience coming by? Well, essentially, you are having more demand for traffic, and that is hitting the limits of the network infrastructure, okay? So here, the network infrastructure is just the connections between different ISPs. And in this graph on the left, what we have is ASP-A and ASP-B, but there are many more, of course. Here we have a scenario that is essentially abstracting this, and we have ASP-A, that is essentially this area here on the top, that is reflecting not only the CDN points of presence, but also some of the members of your audience that they may be in the same ISP, if they are under a large ISP or internet content provider. And you also have other members of your audience that may not share anything with the CDN itself, and they need to get the content from the other ISP, because at the end, the content is not inside their network, right? Okay, everything is fine. You're starting to get the audience coming by, but then when that grows, there starts to be an issue between the networks that are underlying this event. In this example, as a toy example, we're starting to have an issue between ISP-A and ISP-B because there is not enough capacity. Maybe the peering points are congested. can be anything, maybe internet exchange point between those two guys are not able to cope with whatever is going on here, can be anything. But at the end of the day, what happens is that whenever you continue to grow your audience, like here, you have more devices coming by and they start to suffer. They are not well connected to the other networks. In this case, can be through the CDN itself directly, or it can be through other end user devices. Essentially, these two guys over here are going to start constraining the service and also start constraining the quality of experience because they are not able to get the traffic correctly through the connections to the ISP-A. Why is that happening? Here you can see that it's a large surface of contact between ISP-B and ISP-A, essentially with so many arrows being connected through that interface. That interface, at the end of the day, is just an interface between the two ISPs that is usually happening in an internet exchange point. This is just going even deeper into the network. But at the end of the day, you can imagine that they are just network devices that are connected to each other and they are sharing traffic between two networks, ISP-A and ISP-B. And in order to work around that, what can we do, right? In a normal scenario where you don't have ownership of the network and you cannot essentially change the cables or lay down new cables or new servers on the fly, there's little to be done. Okay, you may want to try to change a different CDN provider, but that's not going to be the solution for this problem, because at the end of the day, it may show up at a different point in time, a different area, and you're going back to square one trying to solve it, right? Okay, so in order to solve this problem, we need to have the right information, and also that is going to enable us to find the right tree to solve the problem once and for all, okay? So let's go into that. More information here is not going to, more data is not going to solve the problem for you. Because what happens, again, back here in this scenario, you see that there are end user devices like this one that, okay, it's providing you telemetry if you have a suite that is allowing you to have that visibility, but you don't know what the problem is. You are seeing an impact on the quality of experience. Maybe you have some visibility points across the network, but this is usually happening outside of your control, and that means that it's outside of your visibility, right? So you may have information that is coming in the way of data from the end user devices here, and it's populating your dashboard and it's telling you, hey, something is wrong. Or even you don't have that and you only have the feedback from the audience complaining on social media that the content is not flowing correctly. And then they are starting to complain, fairly so, and then you actually get churn and the audience is leaving, right? So more data is not always better, because sometimes the data is not telling you where the problem is. You're only getting a symptom, but not information of where is the root cause, right? You need to have actually information about the root cause, and information is interesting, is valid, and is the actionable things. Otherwise, it's just data, and data may be good, may be bad, may be wrong, and it's not helping you. What you need is good data that is actually information, and that makes you actionable for you, okay? So now let's see how that information can be captured, okay? First, you need to have visibility on the right data to make it actionable and make it actually information for you. You need to have quality of experience data that are specific for your streaming service. Doesn't count if the data that you're collecting or the data that you are relying on is based on data from the community, from other services or other customers, because it may or may not relate to you. For example, if you have feedback that, hey, CDN A is performing worse than CDN B using community data, it may be the case that for you is not relevant. Or even all the way around, maybe the system is saying, hey, there is a blackout for ISP A in the community, but maybe for you it's working perfectly because your audience is in a different region or a different subnet, right? At the end, what you need is data from your application, from your service, and that is specific from the quality of experience of your audience. That alone is an improvement, but it's still not enough. You still need to have information and visibility of what's going on, not on the last mile on the device itself, but also in the connection points all the way backwards into the delivery chain. That means that you need to have visibility of the network capacity of the entire delivery path, including the last and the middle mile, like the interface that I just mentioned. And of course, you need to have accurate quality of experience data and performance data in order to enable the next step, that is the actual solution to the problem, that is automating and optimizing the network on the fly. With the right information, you are able to do so. How that information is collected? First of all, yes, you need to have collections on the end user devices because quality of experience is happening there, so you need that. But it's not only that, you need to have that information in real time. So we need to have information collected at least at every second in order to make the changes in the network topology before the video players buffers get depleted. Usually the video players are working with a local version copy of the content in order to play it back to the screen. And that usually is between 30 seconds, 30, 35, the usual setup for normal latency, all the way down to 10, 5 seconds if you want to low latency setups. And at the end of the day, you need to make those changes before those seconds get depleted. So you need to have very, very fast actions in order to avoid impacts on the quality of experience of the end users, because congestion can happen anywhere and any point in time. So you need to have that feedback from the last mile, you need to have that real timeliness, and you need to have visibility of not only the last mile, but also all the way back into the different hubs to understand where is the problem, and with that, avoid it, okay? So it's not only having visibility of the end user devices quality of experience, but also the underlying network capacity. That means the connection between the end user devices and also from the end user devices to the points of presence at the bare minimum.